All right, so my iPad cut that video off here. We're going to finish up again. I said that was x squared there, which what I did here then was to multiply both sides by x plus y squared. And I fit it right in between there. Okay. So I got x squared plus 2xy minus x squared y prime is equal to that. I added the x squared y prime to the right. All right, and then I factored out the y prime and divided both sides by what's attached to y prime. Again, sorry for that blemish there. All right, that was example 6. Then let's see. Let's do a few of these. This should be good. So now we want y prime of x. And folks, ooh, I'm going to show you y of x one more time. Writing this as y of x. That's raised to the third. First off, the derivative of negative 2x squared is negative 4x. Derivative of 10 is 0. Derivative of y of x to the third would be 3. Y of x squared times y prime of x. So 3y squared y prime. Move the 4x over. Divide both sides by 3y squared. But that is y prime of x. I want y double prime of x. So if I want y double prime of x, I need to find the derivative of... So I rewrote it here again. Okay. Now that's y prime. That's very important. So now I'm going to use the quotient rule, which is low. D high, derivative of 4x is 4 minus high. So then D low, which, again, another boo-boo. Derivative of low would be 2 times 3, which is 6. Y prime. Now we know what y prime is. Y prime is 4x over 3y squared. So I'm going to substitute that in. That 4x times 3y squared. I'm going to have to clean that up in a second. So first off, this is going to be 12y squared. Again, all over the square of what's below, so that's 9y to the fourth. Now, this again needs to be a 6. Y, again, y prime is 4x over 3y squared. How would this clean up now? So this is going to be 96 over 3, which is 32. Okay. 32. And you had y divided by y squared, so y would be in that denominator. All right, then you're dividing everything by both 9 and y to the fourth. So if you divide this by y to the fourth, y squared would be in the bottom. If you divide that by y, actually the denominator is made bigger, so there's another error that I catch, because you're dividing it, the denominator is made bigger, so it's y to the fifth. If you do 32 divided by 9, well, that's just 32 divided by 9, nothing special there. And 12 divided by 9, though, is 4. I'm just simplifying that, okay, just doing a little bit of algebra. That is y double prime. So again, eventually, here it is, number 8. No more writing y of x. So find y double prime. If I have x squared plus 4y squared is equal to 4, I have here an ellipse. Derivative of 2x is x squared. Derivative of 4y squared would be 8y prime, because it's like 8y of x times the derivative of y of x. So 8y prime equals the derivative of 4, which is 0. Move the 2x over, divide both sides by 8y, divide them both by 2 then. Y prime is a negative x over 4y, which means I need to do the quotient rule, which is low, 4y, derivative high, let's see if I made a boo-boo here, minus high, d low, derivative of 4y would be 4y prime. I know what y prime is. It's negative x over 4y. So I'm going to substitute that in for y prime. A negative times a negative is a positive there. That makes that a negative there. All right, take a look. This is going to be minus x squared over 4y. And then all over square root of what's below, which is 16y squared. So when I divide this right here by 16, that's going to be a 64 in the denominator. When I divide this by a y to the second, that's going to be y to the third in the denominator. And almost made it through. If I divide this by 16y squared, I'm going to have a y in the denominator with a 4. All right, so 4 needs to be in that denominator, and I just simplified it like that. Okay, let's see here. We're going to do this one more. We're going to call it good here at, well, actually 10 of them. Number 10 is actually a pretty poor one. Find y double prime again. So here, sine of u would be cosine u times the derivative of u. Derivative of y is y prime. Derivative of cosine x is a negative sine x equals 0. Move the sine x over. Divide both sides by cosine y. So that's pretty innocent. Y prime is sine x over cosine y. That's simpler than what we were given. At the beginning, we have the quotient rule. Low times derivative of high, which is cosine x, minus high d low. Derivative of cosine y would be a negative sine y times y prime. A negative times a negative is a positive. Again, instead of writing y prime, what is y prime? It is sine x over cosine y. So on this right side, I'm going to have now a negative times a negative is a positive. So sine x times sine y times y prime, which is this. Then I have cosine x, cosine y. All right, so here's how I simplified. This would be sine squared x. And then it's, here I didn't really do much simplifying. Sine y over cosine y. If you wanted to write that as tangent y, there's a few different ways you can simplify. I divided everything by cosine squared y, which on this right side would now be cosine to the third y at the bottom. Here would be cosine x over cosine y, because those two, that would